Okay, so when it comes to resolution of forces into components, there's a particular misconception or a general idea that we have in mind that must be broken. Are you okay? So generally, you've seen this equation, something like this one, right? Where it will be like the resultant force is the actual force is actually the component, right? So F is equal to square root of x, fx squared plus fy squared, right? One thing that we must take note here is that whenever we are doing something like this, we are talking about the magnitude of the force. We are not giving any specified direction or something. So in that case, we are just talking about just the magnitude of the force. So in that, we are just saying, say, we are talking about the scalar component of the force. So everything you are seeing here, whether this x or this y, these are the scalar components of the f or the force, right? In the x direction, in the y direction, just the scalar. It is not giving the direction, just the magnitude of the force, right? So more appropriately, there should be bars here to show that whatever is here is given as the magnitude of the force, right? Nothing else, just the scalar. So that's why we see that these fx and fy are the scalar component of the force. Are you okay? But in actual sense, whenever we see a force, we know that it's a vector, right? It has magnitude and direction. So it's more appropriate that whenever we talk about a force, we talk about the magnitude, we talk about direction too. So if here is diagram 1, diagram 2, this diagram 1 here is a scalar. Are you okay? The scalar something. It's only talking about the magnitude. It's not giving us any direction. Are you okay? But when it comes to this diagram 2, what's happening is that because we are in a 2D system, right? Everything here, these two diagrams, diagram 1 and 2 are in 2D systems, right? And then we are trying to say that we are using this I and then J. In actual sense, if it to be 3D, we have I, J, and then K, right? These are actually unit vectors in math or like in 3D. If it to be 2D system, the unit vectors are just I and J, okay? Depending on what we are doing. What is actually saying that when we try to introduce this I and J, we are trying to introduce the vector component, the vector aspect of it. So here's the case that we're having the force F, right? And to get the full force F is the, because we're in the 2D system, is the S component plus the Y component, right? And then we've introduced the I and J here to tell us that we're actually giving is giving us the magnitude and direction at the same time, right? So this is a complete description of the force F. Okay, this one is just a scalar description. This is the complete description. This diagram 2 here. Are you okay? So whenever you are doing basic mechanics, it's very important, or when you are doing any mechanical analysis of a system, it's very important that we know the difference between these two. Whether when we are doing a scalar description or when we are doing a vector description. Hmm. So for this one, for instance, when we have the f of x component, this is actually how it should be. But then we've introduced this I here to say, we are actually describing it to be to be a force, right? To be a vector having magnitude and direction. Are you okay? The same thing is written this way. So then this I here is this, right? Cos theta I. This theta I here, sorry, this cos theta here is the direction that the force is making in the x-axis, right? And because we are using the same angle here, to find the y component, we use sine this. Are you okay? This is a very simple but fundamental to whatever that we do in basic mechanics. Okay, so imagine that you're given a question like this. Let's say it's OBJ, and it happens to be that they give some of the actions to be this. Let's say 655 newtons, right? And then they have another one. Let's see, because it's a combined. Let's say this A and then this B, right? FYB 459 459 newtons. It's more appropriate to choose this A option because we want the forces. We don't just want the what do you call it, the scalar aspect of it. We want the vertical, and then per this question here, we want the vertical and the horizontal component of the force. So these are the actual ones because this I and J here is actually giving us the direction that in which they are. Okay, so that one is a better description of the force. Are you okay? So here is very simple. We have in a system, and generally because we are in a 2D system, we know the 2D system is this is oriented in this way, right? So if there's the x, there's the y, right? So anything here will be negative x, and here negative y, right? 2D system. So this way, the same thing here. Let's see. So So we're having this, right? So anything that we are doing here, this will happen. Before we even get the horizontal and vertical component, this is what we do. To get the horizontal component, we know that the force is actually aligned in this direction. So right, the horizontal component will be here, right? It to be a negative x. So this f of x here, the negative here is just trying to tell us that it's in the opposite direction. It's not in the actual direction to positive axis. Are you okay? So negative, right? And then to get the magnitude of the force, that's what we have, the f cos a, right? So this negative here gives the direction, right? Whether it's aligned with the coordinate system or it's not aligned with it, right? Then this one here, the f cos a, gives the magnitude, right? So everything here, this was given as this, and finally we get this fd. But then this I here is trying to tell us where we are in the coordinate system. That's all. The same thing for the j. Okay, yeah, so that's what's happening here.